And in this video, I'm going to be talking about exponential functions, how to graph them, and also how to solve them. So first things first, an exponential function is a function where the variable is an exponent and not part of the base. So a base is, like in this case, the base of this example here is 2, and the exponent is x. So this is way different than what you're used to. Up until this point in algebra, you're used to the x being the base and the exponent being a number. Usually squareds and cubes are very common for algebra 2. But this is something totally different where our variable is in our exponent, which is treated a completely different way. And when we graph these things, there's going to be something called an asymptote. And that's a line that the function will approach, but it will never touch. So, on most of these functions, they're going to look like they're going to get really, really close to the x-axis, like as close as you can get, but they're never going to touch. And they're going to slowly increase, and then they're going to go up faster and faster and faster. And so the asymptote on most of these is going to be the x-axis because it's a line that goes across that the graph will, as you work to the left, will get very, very, very close to, but will never touch. And we'll talk about why that happens in a little bit. But that is that's the basics of an exponential function. How do you graph them? Well, we're going to just graph them using a table in the calculator. So in this case, it says graph y equals 2 to the x. Here is that one graphed for you. You'll notice the y-intercept is at 1. The y-intercept is when x is 0. So if you substitute the number 0 into this function, you would have 2 to the 0 power. And anything to the 0 power is 1. Okay, so that will always intersect at this point 1 here. If you make this 4 to the x, like this, 4 to the x, it's also going to intersect at 1. Because if you plug a 0 in for x, anything to the 0 power is 1, it's still going to be the value of the ordered pair 0, 1 is still going to be a solution. All right. It's when you start putting numbers out here that then that number will change, but we'll talk about that a little bit. Where's the asymptote located? In this case, it is on the x-axis. Okay. How do we know it's never going to touch the x-axis? Well, what is the x-axis? The x-axis is where the y value would be 0, is where y equals 0. So if you think about how you can get that to happen, you can see this graph goes to the left. It goes to very, very, very large negative numbers. So if we can pick a large enough negative value here for x, say like negative 1,000, maybe we could get it equal to 0. Let's take the calculator. Let's try that. 2 to the, and try a really large negative number. So let's go with negative 1,000. That's a lie. This is not 0. 2 to the power of, let's go like negative 100. Should at least give me. Yeah, and so this puts it in scientific notation. This is a very, 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 very small number, but it's not the number 0. And unfortunately, your calculator is not smart enough to understand that 2 to the power of negative 1,000 is not 0, right? It's the same thing as 1 divided by 2 to the 1,000. And that's not 0. It's very, very close, though. So that number will never be 0. So this is going to, went backwards. This is going to approach, it's going to approach the x-axis, but it will never touch it. So we're going to say that the asymptote is the x-axis, or that the equation of that line would be y equals 0. When will y be negative? In this case, never. All right, you can try any value you want for x. You will never be able to get this function to be a negative number. 2 to the power of anything will always be a positive number. Even if you choose negative numbers, again, you can see if you choose negative numbers such as negative 1, then you're going to get a half. If you choose negative 2, then you're going to get a fourth. If you choose negative 3, you're going to get 1/8. But they're positive numbers. All right, so there's kind of the overall gist of what a exponential function looks like. And here's another one. Looks very, very similar. You just have this extra times 2 at the beginning. And you might think 2 times 2 and call it 4, like this. This is not true. It's not the same thing. You can't do that because order of operation says I need to do my exponent on the 2 before I can do multiplication. So it doesn't look like it's simplified, but this is simplified here. So to make a graph, we're just going to use the calculator like we did for the other stuff. Let's go to y equals, type in 2 times 2 to the power of x. And then we can look at the graph here just to see what it looks like. Okay. And then we can go to the table to plot some points. So let's do, so negative 2.5, negative 2.5 right there. Negative 1, 1 right there. 0, 2, 1, 4, and then 2, 8 would be off the graph. So you can connect those together with a nice smooth curve. That was pretty poorly done. You don't want it to cross the x-axis though. So when you draw this line, you want it to come down and approach the x-axis, but not cross it like I just did right there. So don't do that. Try to keep it really close though. So where's the asymptote located? Same place, x-axis, axis. Or you could say y equals 0 is the equation of the line, the x-axis. When will y be negative? It says over here, never, never. All right, so where does this stuff apply to real life? There's a lot of things that grow exponentially in the real world. Populations, anything with humans or animal growth tends to grow in an exponential way. So here's a really old graph of population growth in different continents. And you can see how it doesn't increase. It is increasing, on the left side of the graph, but then as you move to the right, it slowly increases faster and faster and faster. And that's called exponential growth. Another place where we saw this was, it's also old, from 3 years ago, was the beginning of the pandemic. And a lot of these graphs they came out with, you could see how the growth becomes exponential. It grows slowly, and then as more people get infected and they infect other people, the growth expands exponentially. And kind of very similar to bacteria growth, grows exponentially as well. So let's go over how we can solve an exponential equation. And to do that, we got to kind of review some of our power rules, our exponent rules. First one is a base to a base. If you see the base appear twice and then multiplied together, this is where we add the powers. So we would combine these into one base and we would just add 5 plus 7, which is 12. The power to power rule was when you have one base and you see a power and then parentheses and then another power outside. And in this case, we multiply those powers together. So this is 3 times 7, which is 21. And another example here, same thing. You have a power of 5 and then you have another power of x plus 2. You're going to be multiplying. However, you have something that is one term multiplied by something that is two terms. So to figure out what this exponent is, we're going to have to distribute the 5. So we distribute the 5 in, we would get 5x plus a 10. All right, and that we're going to do, a lot kind of like that to solve exponential equations. All right, so how do we solve exponential equations? How do we solve this for this variable? The first thing we want to do is make the bases on both sides match, or make the bases be the same. So in this first example, 3 to the x equals 3 to the 5. You have the same base on both sides. The base is 3, which is really good. So when we have that, then if the bases match on each side, then the exponents also have to match. So if this is 3 to the 5th power and it's equal to 3 to some power, the sum power has to be 5. So once we get the bases the same, we can make an equation saying that the exponents are also the same. So we can just write an equation saying x is 5, which solves the equation. And that would be solving the first one. The second one here, the bases are not the same, so we have to make them the same. So we look over at the 2 and we think, can we make a 2 8 to some power? Can we make it a base of 8? The answer is yes, but it would be pretty difficult. The easier way to do it is to take 8 and change it into a base of 2. And how are we going to do that? Well, we're going to do that by asking the question, 2 to what power is 8? And if you're good at that, 2 to the 3rd power is the same thing as 8. Okay, so all I did in this first step is I took the 8 and I changed it into 2 to the 3rd power because they both are the same value. They're both 8. And I still have this power of 3 outside, so that's why I wrote this power of 3 outside here. And now that we have this, we have to simplify the right side. And so we have a power to a power, so we would have to multiply these 3's together. So I would get 2 to the power of x is equal to 2 to the power of, and then again, 3 times 3 is a 9. Now my bases are the same. It's simplified. And so step 3 here says I can set the exponents on each side equal to each other and solve. So my exponent on the left is an x. Exponent on the right is a 9. And I don't have to do any solving steps because it says x is 9, and that's my solution. All right, so that's the easy version, easy question of solving an exponential. So let's go ahead and do these two. So we have a 2 and a 32, so we're going to have to make them both be the same. It'd be pretty hard to turn 2 into a base of 32. However, the other way around, taking the 32 and making it a base of 2 would be the easiest. And you might need to use your calculator. You might need to say, I don't know what power that is, but let me check. So go, So go 2 to the power of, and I don't know, maybe 4. Maybe 2 to the 4th is 32. It's not, it's 16. But if you multiply 16 by 2, you get 32. So we know we need one more 2. So 2 to the 5th power should be the same as 32. It is, so what I'm going to do is I'm going to go ahead and replace that in the first step. Right after I go back. There we go. So on the left side, we still have 2 to the 6x. But on the right side, we're taking 32 and we're changing it as 2 to the 5th power. All right, and then we've got some simplifying to do here. We've got a power to a power on the right side. So we're going to go ahead and change that. And we're going to distribute that 5 in. So that's 5x minus 10. All right, and now we have the same base on both sides. So we can go ahead and set the exponents on both sides equal to each other. So we got 6x is equal to 5x minus 10. And this is only going to take me one step to solve. If I subtract the 5x to both sides, we just get x left on the left there. So, and on the right, we just have our negative 10. So there's your solution, x equals negative 10. Another one over here. Okay, 49 can be written as 7 squared. So we're going to take that and we're going to write it as 7 to the 2nd power. And on the right side, we're going to keep our 7 there. Keep in mind, it is possible that you'll have to change both numbers to make the basis match. If this 7 was I don't know, whatever 7 times 4. If this 7 was a much, much larger number, we might have to change it as well to make them match. So on the left side, we have to distribute. So we got 2x plus, these are very common, these plus 10s. 2x plus 10 is equal to, and then we're not changing the right side. I have the same base, so now I'm going to set these exponents equal to each other. 2x plus 10 is equal to x minus 2, and we'll solve this. We'll subtract our x to the left side. So that gets me x, and we'll subtract our 10 to the right side. And so we're going to get negative 12 over there. And so there's our solution. X is negative 12. I think I might just have these two yet, and that will be it. So there should be a time symbol here. I didn't put it there. So you do have to combine the left side together in this case. So this is a base to a base rule. So if I want to make these into one base of 3, I have to add the exponents. So I'm going to be adding 2x plus x minus 3. And so that's going to get me 3x minus 3. And on the right side, again, I need the bases to match. So I need to have 9 as a base of 3. And so I'm going to change 9 to a 3 squared. Has x outside. And all I have to do is multiply the exponents on the right side here. So that's just 2x. On the left side, I'm not changing anything. Now I have the bases the same. Perfect. So now I can make the exponents be the same. And so then I will solve this any way you want. We'll subtract 2x from both sides. And we'll add 3 to both sides at the same time. So on the left, we're going to get an x. And on the right, we're going to get a 3. And so your solution should be 3. All right, last one over here we're going to do. Number 2 looks kind of tricky because you're looking at 3 and you're looking at 1. And you could be difficult to make 1 turn into a base of 3. And it could also be, it is very difficult to take 3 and make it a base of 1. It's actually impossible. So we're going to work on the 1. Got to think outside the box. But anything to the 0 power is 1. So I can take the right side and I can make it 3 to the power of 0. Don't believe that? Check it with the calculator. 3 to the power of 0 is 1. Any number, 98 to the power of 0, also 1. Negative 98 to the power of 0, not true. There we go. Also 1. Any number to the power of 0 is 1. So I can go ahead and make that 3 to the 0 on the right side. And on the left side, I'm not changing anything. All right, I just made my bases the same, so I can make my exponents set equal to each other. And then we can solve this. So add 7 to both sides, and then divide both sides by 5. And so we get that x is 7/5, or that would be, what, 1.4, I think? Much rather you write 7/5 though. I think that's going to wrap this video up. That's going to be it. See ya.